Good morning, boys and girls. Welcome back for our last lesson here in this unit. We have a quick little one on the intermediate value theorem. Yay! We get our very first theorem here that we're going to have to deal with and know. This is one you're going to want to know by name and by letters, I guess. Whenever we talk about the intermediate value theorem, it is frequently referred to as the IVT, intermediate value theorem. And you can, when you need to use it, you can just say, hey, I know this by the IVT, and everybody knows you're talking about the intermediate value theorem. What the IVT states is that if a function takes on two values, two y values, y1 and y2 at points A and B are like the x coordinates of the points, then it's going to also take on every value of y between y1 and y2 at some point between A and B. Okay? So kind of quick little sketch here, what I'm talking about. You know, if I've got some point here at A, and I got some point here at B, okay, I don't know what the graph does between A and B. I mean, it might go crazy up and down. It might, be a straight line between those points. I mean, it might, I don't know, do all sorts of things. We don't know, it might woo, 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 woo. Okay? All I know is that in order to get from A to B, we are going to have to take on every y value from A to B. That's basically what it says. So if A, well, in this case, I could use this to prove that the function would have to be 0 at some time, because A, obviously, at A, y is a negative value, and at B, the y is a positive value. At some point in time, to go from negative to positive, I would have to cross through and be 0. Okay. Let's say, though, that A is at negative 5 and B is at 15. Okay. I also could use this to prove that, the function passes through 3 or 2. Because to get from, negative 5 to 15, I would have to pass through 3 or 2. That's what the IVT allows us to do. Okay? If a function takes on two values, y1 and y2 at points A and B, it also takes on every value between y1 and y2 at some point between A and B. Okay? That's what the IVT states. And then I just noticed here, as I read it that last time, I forgot a y. Every value. So you might want to fix that. All right, so real quick, here's how we're going to use this. I want to use the intermediate value theorem to show that for at least one moment on my trip, okay? This is a table of values that I recorded on my way to school this morning. Very mathy. And so, at time 0 when I left my house, I guess I was going 62 miles per hour. Very speedy. And then at 17, I was at 54. It's late for work. It took me a long time to get here, too, it looks like. Holy moly. But 17 minutes in, I was 54 miles per hour. 25 minutes in, I was 47, and so on. All right. So I want to use this to show that on my trip, at least at one moment on my trip, I was traveling at an instantaneous rate of at exactly 60 miles per hour. Okay? 60 miles per hour. So when you do this, it's very wordy. I'm going to write up my answer here in a second, and then it'll pop up and we'll talk about it. Good morning, boys and girls. All right, we got one last quick little lesson in this unit on the intermediate value theorem. Yay! It's our very first theorem we get to know and memorize, the intermediate value theorem, frequently referred to as the IVT. This is one you're going to want to know by name and by letters and know how to use. Okay? But the IVT states that if a continuous function takes on two values, y1 and y2 at points A and B, it also takes on every value between y1 and y2 at some point between A and B. Okay? In drawings, here's what we're saying. Quick little sketch. If I have some point at x value A, and I have some point at x value B, if this function is continuous, that's a very important piece of this, the function has to be continuous. But if the function is continuous, it will take on all the y values between y1 and y2, okay, between that lower point and higher point, on A to B. Okay. This can be very useful, like in the case of my drawing here. I know that the point at A, I don't have any coordinates here, but I know that the point at A is negative, a y value, right? And the point at B is a positive y value. So I could use the intermediate value theorem to prove that my function goes through 0. Because to go from a negative to a positive, you're going to have to pass through 0. And that's one of the ways we frequently use this. I don't know 100% what my function is doing on this interval. I mean, it might be a straight line from A to B. It might go and it might have, a bunch of whoop-de-whoops. I don't know how many times it's going to go through 0. I can just prove that it's going to go through 0. Okay? Or I can do this for any value. If this is at negative 5 and B is at 15, maybe I'm going to use it to prove that the function goes through 10. I don't know how many times it's going to go through 10, but to get from negative 5 to 15, it's got to go through 10 at least once. So that's kind of how we use the intermediate value theorem and kind of what it's saying. That if you've got 2 points, you can prove that it's going to hit every y value in between those 2 points. All right. So now let's kind of put this in application with the table I have here. This is a table that I made on my way to work this morning. Okay. It's got the time that I left my house and my speed in my car in miles per hour. When I started tracking myself at time 0, I was on the freeway and I was traveling 62 miles per hour. Not too shabby. 17 minutes later, I was going 54 miles per hour. 25 minutes, I was going 47, and so on. We have our little table here. Okay. Just want to say it took me a long time to get to work this morning, evidently. All right. So I want to use this now. I want to use the intermediate value theorem to show that for at least one moment on my trip, I was traveling at an instantaneous rate of exactly 60 miles per hour. Okay. Can I use my table of speed to show that I was going exactly 60 miles per hour on my trip? All right, I want you to look at this table. I want you to think about what your answer would be. I'm going to pause this here in a second, and I'm going to write up my answer because when you use the intermediate value theorem, it is going to be a bit wordy, and there's going to be some things that you must state. Okay, so let me write up my answer while you think of yours, and we will continue on. Okay, so here's what your justification or your answer should look like. Hopefully you got that I hit 60 miles per hour sometime on the interval from 0 to 17. But here's some things I'm going to look for in your answer. Here's what my answer said. Mr. M would hit an exact speed of 60 miles per hour sometime on the interval 0 to 17. I know this because speed is a continuous function, and at t equals 0, speed is 62 miles per hour. Also at t equals 17, the speed is 54 miles per hour. So by the IVT, at some point on 0 to 17, Mr. M must have traveled 60 miles per hour. Okay, things that are important there that I'm going to look for in an IVT answer. 1. You must state that the function is continuous. So like I had to state that I know the speed is continuous. Speed cannot instantly change from, 3 to 27. It just doesn't, you got to speed up, you got to accelerate. Okay, so speed is a continuous function. You need to state that. You need to state the points that are bracketing what you need. So I had to state that at time is 0, the speed is 62, and the time at 17, the speed is 54. And then I need to state that by the IVT that I'm using the intermediate value theorem. Like I say, by the IVT, I know that, on this interval, 0 to 17, you got to state your answer that I've got to be traveling 60 miles per hour. So you need to state continuity. You need to state the starting and stopping spot that brackets your function, the y1 and y2. And then you need to state the answer. Okay? All right. So let's try another one here. How many times could you say that I traveled 55 miles per hour? How many times did I travel 55 miles an hour? Exactly. All right, go ahead, pause this, look at the chart, think about it, try to write up an answer, and then you can look at mine. Okay, here's my answer. Mr. M would hit an exact speed of 55 miles per hour at least twice. I know this because the speed is a continuous function, and at t equals 0, his speed is 62 miles per hour, and at t equals 17, his speed is 54 miles per hour. Also, at t equals 45, his speed is 54, and at t equals 52, his speed is 57. So, by the IVT, at some point on 0 to 17 and 45 to 52, Mr. M must have traveled, I forgot to change it, 55 miles an hour. Okay, so again, things I'm looking for there, again, the number of times. I said it happened twice. I'm looking for that you say it's continuous. I'm looking for the intervals on which it happens. Tell me where it happens and the endpoints that happens. And then that it is being used, that you are using IVT. Those are kind of like the 4 things every time I'm grading this question that I'm looking for. Okay? One last little question, and we're done. Last question I have is for you. During which intervals did Mr. Mortara possibly reach an instantaneous speed of 50 miles an hour? During which intervals did Mr. Mortara possibly reach an exact speed of 50 miles per hour? Okay, think about that one. Kind of forgot I want to let the video go a little bit. Give you some think time. If the answer just pops up, it'll ruin the surprise. Okay. The correct answer to this one is, when did I possibly reach 50 miles per hour? Could be any time. I don't know. You can't prove or disprove that I hit 50. You can't disprove I didn't hit 50 on any of the intervals. Okay? Going from 62 to 54 on 0 to 17. Maybe I went 50 on that interval. We don't know. Okay? I can't prove it using the IVT, but I also can't disprove using the IVT is the point. Okay? I might go way above and way below. I know I hit all the values between 62 and 54, but I don't know for certain, that I didn't either. Okay? So you can't disprove stuff with IVT is the point of that one. So the answer could be any. Might have hit it any of the times. All right. So with that being said, I hope you enjoyed this video, and I'll see you all again real soon. Bye-bye.